Hey girls, so this video will be about implicit differentiation, which is a skill we need for extension 2. So it relies on asking you how you might differentiate something like, to start with, let's say x squared plus y squared equals 1. So in 3 in it, what you would do is you'd say, alright, y equals plus or minus the square root of 1 minus x squared, and then you would differentiate that. Oops, sorry. Instead, we have a technique that is, generally speaking, a little bit better. And effectively what it is you say, I want to differentiate all of that with respect to x, and I also want to differentiate, I didn't leave myself much room, the right-hand side with respect to x. So you end up just doing the same thing to both sides, which is differentiating with respect to x. So on the right, it's pretty obvious, like the derivative of 1 is 0. On the left, the sum of the derivatives is the derivative of the sum. So first, we differentiate that and we get 2x. And then we're left with differentiating y squared with respect to x. That is equivalent to saying, let's say, y equals 2x plus 1, for example, then y squared is that squared. Right, so to differentiate, you bring down the power, you subtract 1 from the power, you multiply by the derivative inside, you write the inside again. So we do the same thing. We bring down the power, we subtract 1 from the power, and then we multiply by the derivative of the thing on the inside, which is y. And then if I do a little bit of algebraic manipulation, I'll just write y dash now. So that y dash equals minus, and don't get confused, that's a 1 there, not a dash. Minus 2x divided by minus 2y, divided by 2y. So the derivative is negative x over y. So instead of doing this convoluted square root thing, I can do this, and then I know, for example, that stationary points are just when x equals 0. Which, if you think about it, I'll squeeze it in over here, the graph is a circle. Where are the stationary points? There's one there and there's one there. And notice how I found 2 at once. Okay, again, the other thing I wanted to say was that the vertical tangents are when y equals 0. Something like that, right? I'll show you how to do another example quickly, and then I'll just show you a bunch more tomorrow, and we'll do some curve sketching with it. So let's say I wanted to differentiate, I don't know, x cubed plus 2x y equals 3. And I wanted to implicitly differentiate this. So derivative of the left, if the functions are equal, then the derivatives must be equal. Okay, so x cubed is still x cubed, so it's just 3x squared. And now I do the product rule. Now product rule is uv dash plus vu dash. Leave the first thing alone, differentiate the second. Leave the second thing alone, differentiate the first. You've also seen me do it like p dash, e dash, and then do inside plus outside, which is the same thing. So I'll call the first 2x. So firstly, I'll leave that alone, and then I'll multiply by the derivative of y. And then I leave the y alone, and I multiply by the derivative of 2x, and that equals 0. And now I just solve this for dy dx. So 2x y dash equals minus 2y minus 3x squared. Divide both sides by 2x. So I get, minus y over x minus 3 over 2x. And I probably should have done that, but anyway. So then that gives you your stationary points by setting it equal to 0, and it also gives you your vertical tangents. And we can and will use this to help with some curve sketching, but they're generally quite explicit when they want you to implicitly differentiate a function. Okay, and then probably on Thursday we'll also talk about some inequalities, but they're pretty strongly related to extension 1 inequalities. So you should be pretty well prepared for that. All right. Thanks for watching. I'll see you Thursday morning.